Hi guys. Now we're getting ready to look at the differences between GCF, which stands for greatest common factor, and LCM, which stands for least common multiple. We're going to look at a couple of examples on how we use factor trees and prime factorization in order to find the GCF, or greatest common factor, and how we use factor trees and prime factorization to find the LCM, or least common multiple. Our first example is going to be using factor trees to find the greatest common factor of 24 and 32. So first I start with my two branches. Two numbers that multiply together to make 24 are 6 and 4. However, please remember that you could start this factor tree off any way you want. You could have started it off with 8 and 3, 12 and 2, any numbers that multiply together that make 24. 6 is composite, so it needs its own set of branches. 3 times 2. 3 is a prime number. I'm going to circle it. 2 is a prime number. I'm going to circle it. 4 is not prime, so it needs its own branches. 2 times 2. 2 is prime. This 2 is prime also. So I'm going to go ahead and write out that number sentence right now that shows the prime factorization of 24. That's going to be 2 times 3 times 2 times 2. So I've got all the numbers that are circled in a number sentence. Next, we're going to do the factor tree for 32. I'm going to use 8 times 4. You could have used 16 times 2 if you wanted to. We're going to get the same answer in the end. 8 is composite, so it needs its own set of branches. 4 times 2. 2 is prime, so I'm going to circle it. 4 is not, so it needs its own set of branches. 2 times 2. Both of those 2's are prime, so I'm going to circle them. Remember, those circles are like big stop signs that says you're done, you don't have to touch that number anymore. This 4 needs either branches or a circle. It needs branches because it's composite. Okay, so now I'm going to take all of these circles numbers and I'm going to put them in a number sentence to make my prime factorization. So we've got 2 times 2 times 2 times 2 times 2. And now I've got my two number sentences, one for 24, one for 32. As you remember, it's very important that I stack these two number sentences on top of each other. It makes it easier to find pairs, okay? Remember, GCF is couples or group only, no single allowed. You remember from class, it's like going to the dance. You can only go if you can find someone to go with that looks just like you, that's not in your same family. Okay? Here's a pair. These two 2's are going to come together to make one big 2. Here's a pair. These two 2's are going to come together to make one big 2. Here's a pair. These two 2's are going to come together to make one big 2. And remember, your pairs don't have to be stacked exactly on top of each other. I could have circled this 2 and that 2, as long as they're not in the same line. So now that I've found all the pairs that there are, remember, I can't circle this 2 and this 2 because they're in the same line. They're in the same family. I need to multiply what I found together. 2 times 2 is 4, times 2 is 8. The greatest common factor between 24 and 32 is 8. Now, I'm going to show you also why that would come in handy. Let's pretend we had a fraction. that looks like this. And your job was to simplify that fraction. Well, now that you know the greatest common factor, you know exactly what to divide by. "24 divided by 8 is 3. 32 divided by 8 is 4. 24 over 32 is equivalent to 3/4. All right, now what I'm going to do is I'm going to leave those same factor trees up here. Same thing for 24 and 32. I'm going to leave those up there. This time, we're going to find the least common multiple of 24 and 32. Now, those are big numbers. Those are big numbers. So you want to do the factor trees when the numbers are big. When the numbers are small, you can just list them out. I'll show you an example of what that looks like also. All right, so my trees are already completed for 24 and for 32. I'm going to do the exact same thing. Take my circle numbers, write them down in a number sentence, and stack them on top of each other. Prime factorization for the number 24. Here's my prime factorization for the number 32. This time, we're going to find the least common multiple, the LCM. Remember, everybody gets to go to the dance on this one. Not just couples only, not groups only, singles are allowed. But first, since we've got a couple of numbers, we're going to look for the couples first, like this. Same process. Those two twos are going to come together to make one big 2. Here's another couple. Those two twos are going to come together to make one big 2. Here's another couple. Those two twos are going to come together to make one big 2. Now we're left with all the singles. The singles are good to go to the dance as well. Here's a single. That single gets to go. Here's a single. That single gets to go. And here's another single. That single gets to go too. This is a long string of numbers that we're going to end up multiplying all together. The biggest difference between GCF and LCM, GCF, couples and groups only. LCM, least common multiple, everybody gets to go. We make sure every number is taken care of. Every number is represented some kind of way in this number sentence. Now, let's multiply it out. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. And 32 times 3 is, I'm going to have to multiply that one out myself. 32 times 3 is 96. Thank you, camera person. 96. So our least common multiple for 24 and 32 is 96. That means if I count by 24s and if I count by 32s, the smallest number they're going to have in common is 96. All right, now remember I told you I would show you what it looks like when you're finding the least common multiple of smaller numbers, like 4 and 6. When they're small, you don't have to do the number tree. You can. It'll work the same. But you can just make a list. 4, 8, 12, 16, 20, 24. That's my list of 4s. Here's my list of 6. 6, 12, 18, 24. Now, I see they've got some stuff in common. They've got a 12 in common. They also have a 24 in common. But remember, I'm looking for the LCM, the least, the smallest number they have in common would be 12. Okay? That number comes in handy, and I'll show you why next. Stay tuned for another video, and thanks for watching.